We are going to get started in section 10.2 today. Now, in this section, we want to talk about rational exponents, and we're going to start out by talking about exponential notation. So let's start out by looking at this expression here. Now, if I have 5 to the 1/2 power, okay, 5 to the 1/2 as your exponent, and I want to try and square this expression, okay? So basically, anytime you square an expression, you are saying whatever the base here is, you're multiplying that into itself twice. So this would give me 5 to the 1/2 times 5 to the 1/2. Okay. Now, if I wanted to find out what the value of this expression is going to be, I could go ahead and apply rules of exponents. Okay, so let's say by rules of exponents, this thing would be 5 to the 1/2 times 5 to the 1/2, where when you have the same base, you can add your exponents. So 1/2 plus 1/2 will give you, since you can see you have the same denominator, you can go ahead and add the numerators, which will give you 2 over 2, or as we know that as 5 to the first power, or just 5. Okay, so this was applying the rules of exponents to go ahead and evaluate what this expression would mean. Now let's consider if we had something of this form, okay, and we saw this in section 10.1, where if I take square root of 5 and I square that, which is of course, you know, the same thing as square root of 5 times square root of 5, and I know the value for that expression also is 5. Okay, so when I applied rules of exponents to this expression and evaluated it, I ended up with 5 as my answer. When I use the definition of a square root and go ahead and square that expression, I also ended up with 5 as my answer. So what that means is basically that this expression 5 to the 1/2 square is equal to this expression, which is square root of 5 to the 2nd power. Okay, so the difference between these two is basically that instead of writing this as square root of 5, I am writing it as a rational exponent, or in the form of 1/2, instead of writing it as square root of 5. Okay, so let's go ahead and look at a formal definition for this. Okay, so here you have, anytime you have the expression a to the 1 over n, where a is your base and 1 over n is of course your exponent, the idea is if you have nth root of a, which is a real number, then you can write the nth root of a as an exponential number, which would be a to the 1 over n. You will see this n is the same as this n in your as your index for your radical. Okay, so this is what we mean by rational exponents, where your exponents are basically fractions. So let's go ahead and try and evaluate some examples here. Now you have negative 16 and the whole thing to the 4th power, 1 over 4. If I had to write this as a radical, how would I do that? Again, remember, 1 over n becomes the nth root. So if you have 1 over 4, that will become the 4th root of whatever your base is, which happens to be negative 16. Now, if you remember from section 10.1, we had talked about it. If you have a negative number inside an even radical, that is not a real number, because you cannot have a negative sign inside an even radical. So you cannot take it any further than this. Let's take a look at another example. You have negative 121 to the 1/2 power. Okay, now you will see the difference between number 1 and number 2 here. In number 1, we had negative 16 in parentheses and then the exponent of 1/4. In number 2, you have negative 121 and then the 1/2. What this expression means is basically that the 1/2 is only on the number 121 and the negative is outside. So when you convert this into a radical, the negative will stay outside, okay? And then you take the square root of 121, okay? So again, it's the same thing. You had 1 over n, and when you convert it into a radical, it becomes nth root of a. But remember, with square roots, you do not put a index number on your radical. So if I evaluate this further, I will end up with negative 11 as my answer. Square root of 121 is 11. Okay, let's look at another example here. You have negative 32. Again, you will see negative 32 is in parentheses, and then that is to the power of 1/5. So when I write this in the radical form, I will have 5th root of negative 32. Now with odd number roots, like you have the 5th root here, you can evaluate negative numbers. So go ahead and find out what would be the 5th root of negative 32, and you should end up with negative 2 as your answer. If you want to verify this, take negative 2 and put it to the 5th power and see if you end up with negative 32 as your answer. All right, one last example. 8 over 7 and the whole quantity to the 1 over 3 power, or 1/3 as your exponent. So if I write this in a radical form, that will be cube root of 8 over 27. And then go ahead and evaluate that further. Cube root of 8 will be 2. Cube root of 27 will be 3. And that's going to be your answer to that expression there. Okay? So you want to try and get comfortable of writing the expression either as an exponential format or, of course, in the radical format. So